What do circles have to do with square numbers? On the surface, absolutely nothing. What if you take every square number, 1, 4, 9, 16, turn them into fractions and add them up wherever? The answer contains pi. This is the Basel problem, the riddle that stumped the world's greatest geniuses for 90 years until young Leonhard Euler found a ghost in the equation. Take a look at the series, 1 plus 1 over 4 plus 1 over 9 plus 1 over 16. Well, know that the series does not go to infinity. But for nearly a century, no one could find the exact perfect value. Most people were looking at the numbers. We can see that these are the sum of the reciprocals of the squares of 1, 2, 3, 4, etc. Euler, instead of looking at the numbers, looked at the sine wave. You might remember the Taylor series from calculus. It's just a way to write the sine wave as an infinite polynomial. Sine of x equals to x minus x cubed over 3 factorial plus x to the power of 5 over 5 factorial. Well, he divided everything by x to get a function that equals to 1 when x is 0. You can see that sine of x divided by x, this is equal to 1 minus x squared over 6 plus x to the power of 4 over 120. So you can see that when x equals to 0, this equation equals to 1. And keep your eye on the negative x squared over 6. This is the key to the entire mystery. Now, Euler knew that a sine wave is 0 at pi, 2 pi, 3 pi, and so on. He treated this infinite series like a simple quadratic you see in algebra, writing it as a product of its roots. Sine of x over x equals to 1 minus x squared over pi squared times 1 minus x squared over 4 pi squared times 1 minus x squared over 9 pi squared. See those denominators? 1 pi squared, 4 pi squared, 9 pi squared. The squared numbers have officially entered the chat. Euler realized these two equations were the same thing. To find the sum of our squares, he just had to compare the x squared terms from both sides. On one side we had negative 1 over 6. On the other we had negative 1 over pi squared plus 1 over 4 pi squared plus 1 over 9 pi squared. When you set them equal and multiply by negative pi squared, the magic happens. The result, you can see that if this equation, if you have negative 1 over 6 equals to negative 1 over pi squared plus 1 over 4 pi squared plus 1 over 9 pi squared, then the result is just going to become pi squared over 6. It's one of the most beautiful coincidences in math. A list of simple squares sum up to exactly 1/6 of pi squared. It proves that geometry and arithmetic are two sides of the same coin. This wasn't just a clever trick, it led directly to the Riemann zeta function and the most important unsolved problems in modern math. So you can see that even the simple numbers have a cosmic secrets. Hit subscribe if you want to see where pi shows up next. And thank you for listening.